Hello, welcome to my course Introduction to Market Structures. So, in the last class we have done Stackelberg quantity competition and today we are going to do Stackelberg price competition. In Stackelberg quantity competition we have seen that if the reaction functions are linear and downward sloping, then there is always a first movers advantage. So, it means that a firm which chooses output first, it makes higher profit than the firm which chooses output secondly or in stage 2. So, here today instead of quantity, firms are going to choose prices. So, again we assume more or less similar setup. So, there are two firms, firm 1 and firm 2, and it is a duopoly market. Now, here what is different in this setup is that the products are differentiated. Okay? So, differentiated products means they are not perfectly substitutable. So, the goods can be either complementary or they are substitute in nature. So, what does it mean? So, when I say substitute, it is not a very close substitute. It is something like the different brands, they substitute their product in terms of quality. So, in that sense we make this assumption that they are substitutable. And complementarity, here it means that goods are completely complementary. That means if I want this good one, then I will also demand good 2. But if it is substitute, then if I demand good one, then I will not demand good 2. Okay? Like if we think of goods having differences in terms of some attributes or in terms of some qualities like this. Okay? But though that is not explicitly modeled here, we only modeled it in a very simplest form. So, firm 1 produces good 1 and firm 2 produces good 2, and the demand function of good 1 is of this nature. So, demand function is A minus P1 plus B P2 is equal to Q1. So, P is the price of good 1, P2 is the price of good 2, and B denotes the degree of product differentiation. Okay? And here A is a positive real number and Q is the output. So, if you look at this demand curve, it is again downward sloping in this P1. This is the price of good 1. So, it is again downward sloping. We will come to this slightly later. Next, the demand for good 2 is again like this, A minus P2 plus B P1 is equal to Q2. Here P1 is the price of good 1, P2 is the price of good 2. B denotes the degree of product differentiation. So, it is same as the B earlier that we have so used in the demand for good 1, and Q is the quantity demanded of good 2. See, B is the degree of product differentiation. If B is positive, then good 1 and good 2 are substitute in nature. So, it is something like this. So, demand, if it is like this. Now, here if B is positive, that means what? If P2 suppose increases, that is if P2 increases, Q1 increases, demand for Q1 increases, that is good 1 increases. So, good 2, when the price of good 2 increases, demand for good 1 increases. So, that means they are substitute in nature, because the moment the price of a good increases, we reduce its demand. So, that is why they are substitute in this case when B is positive. Similarly, here also we will get same thing. If B is positive and if price of good 1 increases, then quantity demanded of good 2, that is going to increase. Okay? So, people will substitute buy more of good 2 than good 1 when the price of good 1 increases. Okay? So, this is the case. Now, if in the same demand function if you take this, and now suppose B is negative. So, that means what is happening? If P2 increases, price of good 2 is increasing, then this portion is increasing. So, this and it is negative. So, Q1 falls. So, here when the price of good 2 increases, demand for good 1 is also going down. So, goods are complementary here. Okay. Similarly, if we take this good and suppose B is negative, then when price of good 1 increases, Q2 falls, because the complementarity goods are they are going to be consumed together. They require in certain ratio or in some like pen and refill, or desktop and mouse, something like those kind of things. So, so since it is complementary, so if the price of one good increases, so that is the demand for that good is going to go down. So, the demand for other good is also going to go down. So, in this way there is product differentiation between firm 1 and firm 2, and how they are doing this product differentiation, we are not going to do that. Okay. So, we will come to that later on when we do product differentiation. Now, we specify the cost function. Cost function of firm 1 is C1 into Q1 plus F. So, C1 is some positive number. So, if we have a cost function like this, then we know the marginal cost of firm 1 is a constant, and it is C, and it is C is positive number. Similarly, the cost function of firm 2 is of this nature, C2 into Q2 plus F. C2 is a positive real number, is a positive real number. So, the marginal cost of firm 2 is C2. So, it is a constant marginal cost. Okay. Now, we define the game, how, what actually the firms chooses. So, firm 1 chooses price in first. So, it is stage 1, and firm 2 after observing the price of firm 1 chooses price P2. So, it is stage 2. So, here firm 1 and firm 2 decides price sequentially. So, firm 1 chooses price first, and then firm 2 chooses price. Okay? And so, that is why it is a Stackelberg price competition, because they are choosing price. So, price, and since it is decisions are taken sequentially, so that is why it is Stackelberg. Now, generally when we do Stackelberg price competition, we take differentiated product market. Why? Because we have seen that if we take homogeneous good market and if there is a price competition, then we also have seen something called a Butler paradox. So, only Butler paradox when we do not see any Butler paradox, when either there is a capacity constraint or there is decreasing returns to scale. So, that is why we bring in product differentiation to move out of Butler paradox. Okay. Now, in this setup, what we have defined now, like the cost function and the demand function, the way the products are differentiated, that can be studied as a Butler competition in where prices are taken simultaneously, or the firms choose their price simultaneously. So, then it becomes a Butler competition in differentiated product market, but we are not going to do that, and it is same, almost same, there is no difference. So, it is simply more or less same as the Cournot competition, only here it is price and in Cournot it is quantity. Okay. But in this Stackelberg price competition, why we are going to do it? We will see that the end that we get a very interesting result. Okay. So, we are going to do Stackelberg price competition. So, it is prices are decided sequentially. So, that is why since it is an extensive game, so we are defining the action set. Now, the action set is not same as the strategy set. Here strategies are mainly in a dynamic game, we define a strategy for an strategy is a set of complete set of action in all contingencies. So, here since it is a continuous state, we cannot define the contingency in that way, because each price in a range are going to be because P1 can take many possible values, and then we have to define P2 for each such contingencies. So, that is it is not possible, or we can do it using something called a reaction function, and we will do that actually. Okay. So, the action set of firm 2 is this. Okay. So, firm 1, now the profit of firm 1 it is going to be function of P1 P2, and it is this, and profit of firm 2 it is this. This is what? This is the demand function. So, it is quantity Q1 into P1. So, this is the total revenue minus this is the total cost, because this is the Q1 quantity of good one, C1 into this portion, this is the quantity. Now, so total revenue minus total cost, so gives me the profit. Here this portion is the quantity demanded of good 2 into price. So, total revenue, this is C2 marginal cost into the total output or the total quantity demanded, or that is being supplied by firm 2. So, it is A minus P2 plus BP1, this is the demand function of firm 2 or good 2. So, this is the total cost, this portion is the total cost. So, total revenue minus total cost gives me the profit. Okay. Now, so these profit functions are the payoff functions of firms. So, we will use subgame perfect Nash equilibrium as a solution concept in this case, and we will find out the SPNE through backward induction. So, what we do? So, first we will solve the stage 2, which is going to be the last stage, assuming that there is a P1 in stage 1. So, we will get a reaction function of firm 2 in that when we optimize P2. So, we will know that if P1 is takes a specific value, we will know what is the optimal value of P2 based on that reaction function. Now, firm 1 will know this reaction function, or firm 1 can compute this reaction function, and firm 2 instead of taking P2 as given, what will do, it will take that reaction function as given, and based on that it is going to decide its optimal P1. So, it is something like this, that in stage 1, in this stage 1, P1 is decided. Okay. So, P1 takes some value here to some positive number like this, any point, and suppose this is, and then after observing this, firm 2 is going to decide. So, this is firm 1 and this is firm 2, and this is stage 2. So, here P2 is going to be decided, here P1 has been decided. So, this is stage 2. So, we solved first this, and taking the optimal solution in this stage, we solve this. This is the way we solved a dynamic game. Okay. So, let us solve this. Stage 2, P1, since this is a differentiable function, so we can take the partial with respect to P2, and we will get this is form 2, so it will be P2. Now, first order condition gives me that is equal to 0. So, I get so this is the reaction function of form 2. We have got this. Now, based on this, we will, so this is the stage 2. In stage 2, we know this, how form 2 is going to. So, stage 1, form 1 is going to use this. Form 1 profit function is this. Fixed cost, I have forgotten to put the fixed cost. Okay, this. Now, form 1 knows how P2 is going to be decided. If it chooses P1, what is going to be the P2? It knows from this reaction function. So, form 1 will plug in that value here, that function here instead. It will be this, then this portion will remain same BC2, this is going to be plus B square and there it is going to be minus. So, it is going to be minus 2 P1, sorry, it is going to be this minus C1. So, again here it is going to be the same thing. So, A plus B, sorry, 2A plus BC2 minus this. Okay. Profit of form 1 is this. So, here it was this function of P1 and P2. If you look, it is a function of P1 and P2, P1 and P2, P1. Now, P2 it knows it is given by this reaction function. So, this becomes only a function of P1. Now, we know again this is a differentiable function. So, this gives me it is this, and first order condition gives me this is equal to 0. So, we get is equal to P1. This is stage 1. In stage 1 we get this P1, and in stage 2 we get this. So, in stage 2 now we will get P2 as, so this is the reaction function of form 1, form 2. So, plug in the value of optimal value of P1. So, it is this. So, it will be is divided by 4 this. So, P2 is actually equal to is this. And here when we state the SP and E, we say that P1 is equal to a this, P2 is given by this reaction function SPNE, and the actual outcome is actually this, P2 is this and P1 is this, because when you plug in this here we get this. Now, we can compute the profit function, but profit function is going to be a very messy thing here. It will look a very messy, because profit function now it's, you can write it in this form. So, plug in the optimal values, subgame perfect Nash equilibrium, and this is going to be C2 this, where P1 is, P1 takes this value, P2 takes this value. So, I am not putting this value because it will look very messy, but you can do it. But how do we compare this? We are not going to compare profit of firm 1 and firm 2. What we are going to do, in fact, you can also do it for, but it will be better if you take the C1 and C2 as same, then it will make sense. Otherwise, it is again it will be very conditional statements. But we will see whether there is a first mover advantage or a second mover advantage. How do we do that? So, we now check whether first mover or second mover advantage. Okay, we do that. How do we do it? We see, we have already know the reaction function of farm 2. We have derived it. What we have got? Reaction function of farm 2 is this. So, if we plot this, this is P1 and this is P2, we get a curve like this, where this point is like this when B is positive. So, first let us take the case when good 1 and good 2 are substitute. So, B is positive and further B, why it is less than 1? Because if it is greater than 1, then see in this demand function, if it is greater than 1, then the effect of P2 will be more on good 1 than P1, effect of P2. So, that is why this is always taken as this as less than 1. Okay. And when it is 0, there is completely unrelated, they are not. So, we take this here and we get this reaction function, which we have already done. Again, we know the profit of farm 1 when farm 1 is this. This, taking P2 as given, we get this. Again the first order condition gives me that this is equal to 0. So, this gives me it is this. So, this is the reaction function of farm 1 and we have assumed that B is this. So, goods are substitute. So, this is going to be, this is going to look like where this, and in this case the slope of this is going to be what, 2 by B, it is positive, and in this case slope is going to be dP 2 by dP 1 it is going to be B by 2, right. So, it is positive again because B is positive, it is this, but slope of this is less than this. So, we get that this and this is this. This is the outcome when these two reaction functions intersect. So, we say this to be when both the price are decided simultaneously. So, this is the Bartra competition when there is product, when there is differentiated product market. Okay? Yes. But what we are dealing here? We are dealing with Stackelberg. So, Stackelberg case is when the farm 1 decides its output first and farm 2 decides its output second, but you can reverse the sequence also, it does not matter. Okay. Now, but we were trying to find out whether there is first mover advantage or second mover advantage. In the last class also, when we did the quantity competition, we did that analysis based on the Cournot reaction function. So, here we will do the analysis based on the Bertrand reaction functions. Now, in this case the isoprofit curves of farm 1, because farm 1 knows the reaction function of farm 2. Farm 2 also knows this reaction function of farm 1. So, this you can say this is the reaction function of farm 1, which is A plus C1, B P2, this, and this is the reaction function of farm 1, where it is sorry. Okay, this. Now, isoprofit function is this profit when we fix the level of profit and then look at the combination of P1 and P2. So, this you can this. Now, if we fix P1 and if you keep on increasing P2, since B is positive, so this portion, this is fixed, this portion is increasing, this portion. So, that means if I fix P1 suppose here and then keep on increasing P2 like this, what is going to happen? Profit is increasing, right. So, profit increases in this horizon, in this vertical direction, okay, because goods are substitute, right. Because when the price of good 2 increases, keeping the price of good 1 fixed, the demand for good 1 is going to increase, because people will shift from good 2 to good 1, because price is increasing. So, that is why its profit is going to be increased, because more quantity will be demanded. Now, so we know this direction. Now, how this function, how it looks. So, if we find the total differentiation of this, we will get this what? This, and when we are moving along an isoprofit curve, this is equal to 0. So, the level profit level is fixed. So, we get this. Now, here if you look at this, this is what? This is the reaction function of farm 1. Of farm 1, and this portion since P1 is always going to be greater than C1 because C1 is the marginal cost, otherwise too we will get the Butler paradox. So, this portion is always positive because B is positive and P minus C1 is positive. So, this portion is always positive. So, the sign of this, how P1 as P1 varies, how the curves look like, this isoprofit curve, this depends on the sign of this reaction function, and we know this reaction function in this portion it is negative because P1 is at this point. If we fix the P2 at this point, P1 is, then that reaction function is, this function is because this is equal to this. So, if we fix P2, P1 at this level it is going to be such that this takes a value 0, but if it is less it is going to be what? Positive, and since this is positive and this there is a negative sign, so it is going to be negative. But if P here it is, this is greater than this, so this is going to this minus this portion is going to take a negative value. So, here it is a negative sign, so it is going to be positive. So, we get suppose this is suppose this is the reaction function of form 1, and this is the reaction function of form 2. So, the isoprofit curves are going to be like this and they are increasing. So, profits are increasing in this direction. This is the reaction function of form 1 and this is the reaction function of form 2. This is the Butler outcome, and the Stackelberg outcome is such that it is going to be tangent. So, it is suppose this point. So, Stackelberg is going to be this. So, what do we get? I will draw this again. This is the reaction function of form 2, this is the reaction function of form 1, and isoprofit curves are like this. So, it is here, and we will get a curve like this, and this is suppose this is the Butler outcome when both the firms decides the price simultaneously. This is the Stackelberg when firm 1 moves first and firm 2 moves second, like this. So, now if it chooses any other point here, because firm 1 knows firm 2 is going to choose based on this reaction function. So, it will choose that point in this reaction function which will give it the maximum profit, and profits are increasing in this direction, right. So, if you take here, so it will be below, if you take here it will again below this, and as this is the isoprofit curves which is tangent. So, any other point it will be such that that isoprofit curve passing through that point will be lying below this. So, the profit is going to be less. So, that is why the isoprofit curve tangent to reaction function of firm 2 gives the Stackelberg outcome. Okay. So, the Stackelberg outcome that we have computed, we have got it in this way when B is positive, that is goods are substitute. Now, look in this way. So, we have got this. Similarly, the isoprofit curves of farm 2 is going to be something like this. Yeah, it will be like this, it will be like this, and it will be somewhere, sorry, it will be something like this. Then this is the Stackelberg outcome when, so this green one, this gives me the Stackelberg outcome when farm 2 moves first and farm 1 moves second. Okay. Now, if you look at this, see what is happening. It will be such that it is going to be tangent, right. The moment it is tangent to this, what is happening? It will lie above this, because there is a highly unlikely chance that it is going to be tangent. So, if it is like this, then it means what? The isoprofit curve of farm 1 is here, but when it moves first, it is here. So, this is above this. So, what happens? When farm 2 moves second and farm 1 moves second and farm 2 moves first, then actually farm 1 gets a higher profit. So, now it is here, right, and if you look at this, yields are increasing, it is this, but if it moves first, farm 2 moves first, then its A will be somewhere here, because it will be based on this reaction function. So, that is why farm 2 gets higher profit when it moves second and when farm 1 moves first. So, what do we get? When farm 1 moves first and farm 2 moves second. So, profit of farm 2 here when it moves second, this is going to be greater of farm 2 when it moves first. When farm 2 moves first and farm 1 moves second. So, this is the case. We have got it from this. So, what is happening? This is the isoprofit of farm 2, but if it moves first, its isoprofit is going to be somewhere here. It will be based on this reaction function, right, because it will choose that point in this reaction function of farm 1 which will give it the maximum A. So, it will definitely going to be lie below this. So, because this A is never going to A, because this is tangent at this A. So, that is why farm we get there is always a second mover advantage. So, what we get? We get that whenever the reaction functions, so this result we write it in this form, when the reaction function of farm 1 and farm 2 are linear an upward sloping there is second mover advantage. So, this means when they are upward sloping, this means good 1 and good 2 are substitute. Okay? If it is not substitute, then the reaction functions would not have been upward sloping. We have got it from this. Now, in case of complementary goods, we know in case of complementary goods, that is good 1 and good 2 are complementary. So, that means B is negative and B is greater than minus 1. Okay. So, reaction function is profit of firm 1 is this. We know the reaction function of firm 1. This is going to be a negative portion part. So, going to be like this. So, this reaction function, if we take price of good 1 here, price of good 2 or price of firm 2 here. So, this is negative, this portion, because B is negative. So, what it will be? So, if this is 0, it is going to be A plus, and if this is 0, this is going to be divided by minus B. So, it is positive number, we will get like this. Similarly, the reaction function of firm 2, it is going to be A plus C2 it's going to be like this. Sorry, this, and since this is going to be negative, so when this going to be like this and this is, so this is positive like this. So, it is going to be like this. This is going to be the price when they are choosing the price simultaneously. So, this is Batraye. Now, in this case what we have done? We have assumed that the goods are complementary and firm 1 chooses price first, firm 2 chooses price second, and the profit function, the isoprofit curve is this. Now, when P2 increases, since B is negative, this is going to go down. So, this is, so profit in this direction, it is going to go down. reaction function of form 1, reaction function of form 2. So, again by simply looking at this, we get this to be now B is negative. So, since B is negative, P1 minus C1 is positive. So, this is positive. So, this whole term is negative. So, this is whole term is positive. So, this when prices are here, this portion reaction function, this takes negative value, and when it positive value, and when it is here it is taking negative value. So, the isoprofit curves are going to be like this, okay, and profit is going to be higher here. So, again it will be, this point is going to be some Stackelberg price, and this is going to be Stackelberg price, right. Now, here if you look at this A, so this is when they move here. Now, when farm 1, if you look at farm 2, it will be at, so the of farm 2, this is the reaction function of farm 2. So, it will choose that it is tangent to this one. So, this is the Stackelberg. Now, whether there is a first mover or second mover advantage. Now, in this case you will see that this point should give it, farm 2 the maximum profit, and this is when they move simultaneously, and this is when farm 2 moves second and farm 1 moves first. So, here this is going to give it a higher profit than this. So, farm 2 has a disincentive to move second. So, we get that again there is a first mover advantage when reaction functions are downward sloping and linear. So, this is the case when good 1 and good 2 are complementary in nature. When they are complementary, then we get the result is same as the Kuno, as the quantity competition, and when there is no homogeneous product. But when the goods are substitute, we get that there is a second mover advantage, and we show that second mover advantage based on this, that if farm 2 moves second, it will be in this isoprofit curve, and the isoprofit curve of farm 1 is this, because it is tangent to this. But if it, and this is always going to lie above any isoprofit curve that is tangent to this, because this is the reaction function of farm 1. So, that is why farm 2 here is going to gain by moving second rather than moving first or moving simultaneously along with farm 1. Okay. So, with this we end the Stackelberg competition, and for this portion price competition, this class notes is sufficient, and it is more or less straightforward. It is not very difficult. Only problem is when you have to find out the whether there is a first mover advantage or a second mover advantage, and it is better if you do it based on the diagrams rather than comparing those algebraic expressions, because these algebraic expressions are going to be very messy in this situation, because we have got the, because this is the price of firm 1, and when we plug in this reaction function, we get the price of firm 2 in this form, and we have to plug in this function. So, this is going to be a very messy thing, but we can find out whether we can find out a way to compare the situations, whether there is first mover advantage or second mover advantage, based on the diagrammatic analysis or based on the analysis of the graphs. Okay. So, this portion you can look at from these notes is sufficient, and if you compare it with the quantity competition, you will see if in the case of complementary goods it is same as the quantity competition, even if we are doing a product differentiation. Okay. So, with this I end this portion. So, thank you.